You are watching the Exponential Growth and Decay Day 3 Notes video. In this video, we are going to basically go backwards with what we were doing from days 1 and 2. And in order to be able to, what I mean go backwards, is we're going to be taking the equations and interpreting what the different parts of the equation mean in context of some real-world applications. So in example number 1, it asks us to complete the table for each exponential equation. In order to do so, we need to identify the parts and then also figure out if we're dealing with percent increase or decrease. So the first thing that I want to identify, and I'm going to look at the structure consistently between all of the different exponential functions you see here, is we want to find the initial value. So the number in front of the multiplier is our initial value. So we're looking at 62, 7, 325. The next piece is to determine if it's exponential growth or decay, which I think many of us can identify at this point. So we look at the multiplier. If it's bigger than 1, it's growth. If it's smaller than 1, it's decay. Bigger than 1, growth. Bigger than 1, growth. Now here's the tricky part. This is where we have to interpret the multiplier. So right now I'm just going to write the multiplier off to the side here. So 1.5, 0.28, 1.025, and 2. Now, just looking at this, this does not look like a percent because it's not. This is a decimal. Now remember, we got these numbers in the past few days by moving the percent decimal place 2 spaces to the left to write it as a decimal. So we're going to go backwards, and in order to write our decimal as a percent, we're going to multiply 100 or move the decimal place 2 spaces to the right. So that becomes 150%. This becomes 28%. This one becomes 102.5%. And this becomes 200%. Okay, so now I haven't really decided if this is percent increase or decrease yet because I haven't compared anything to 100. So the easiest way that I find is just to subtract 100 from each of these values. So 150 minus 100% is a positive 50. So this means we're looking at a 50% growth, and that makes sense because we were looking at a growth function. Okay, we could do 28 minus 100, which is negative 72, which means this is a 72% decrease or decay. Same thing with this example, 102.5 minus 100. We're left with a positive 2.5%, which means that's a 2.5% increase. And the same thing with this example here. This one's a little tricky and strange, but we can still subtract away 100. And then this is a 100% positive leftover, which means 100% growth. So now that we've talked about the ways that we can break down and interpret each of those numbers, let's see what this looks like in a problem like this. Okay, the first thing that I just want to take a look at is that there are a couple errors here. So in example number 1, it says 120,000 means that there were. So I'm just going to erase this, and then I'm going to get rid of that. Okay, so number 1, it says the value of a home can be represented by this equation where t is a time in years. And they're saying, what does this 120,000 and 1.018 mean in the context of this problem? Well, many of us know that because a number in front, that's our initial value, that's the start. So what are we talking about here? Well, this is the value of the home was what? Well, this is 120,000. When did this happen? Well, at the start. Okay. Now, this is the trickier part. So now we have this number, but we want to interpret it as either a percent increase or decrease. Many of you will look at the multiplier and you're like, oh, that's a percent increase. You are right, but let's figure out what that is. So we move the decimal place 2 spaces to the right, and this becomes 101.8%. And if we compare that to 100%, we end up getting 1.8%, and it's positive. So because it's positive, that means that what is the time frame? So every year, the home value does what? Well, it was positive, it increases by 1.8%. Okay, let's see this in action with another question. So this function down below here is 500 times 0.98 to the x power, represents the population of a beetle in South Africa, where x is measured in years, and we need to explain what the 500 and the 0.98 mean in the context of the question. So what does the 500 mean? Well, the 500 means there were 500 beetles at the start. And then the 0.98, again, this is the tricky part. So the 0.98, let's give this a little math love first. So 0.98 as a percent is 98%. And if we subtract 100 from this, we're left with a negative 2%. So what does this mean? Well, what is a time frame? So each year, the beetle population decreases by 2%.